Hello friends, welcome all in the third video lecture of chemical kinetics. In this lecture we will discuss some graphical confirmations and nature of the graphs for concentration and time. So if you look in the screen, the first graph, that is graphical representation in graph 1, it looks that there is a straight line with slope, and in the another graph you will see a horizontal line. We will see one by one. So graph 1, if we plot a graph of concentration against time, it is a straight line with negative slope. The slope is negative because this straight line is in the decreasing order. As time increases, concentration of reactant decreases. So it has an intercept, that is intercept on y-axis, that is distance from origin O up to the uh, point present on y-axis. So that distance should be considered as the intercept for this graph. So negative slope is due to rate is constant. Rate remains constant even though as time increases, concentration of reactant decreases. It is independent upon the concentration of reactant. So this is the explanation for graph 1. For graph 2, if you look, as concentration is continuously increasing, the nature of the graph is a horizontal line or it is parallel to the concentration axis, but values on y-axis, that is the rate, is remain as it is. That means rate is constant whether you increase or decrease the concentration. So if you plot the graph rate against concentration, we get a straight line parallel to the concentration axis. So we will go to the next slide. There are some important graphs which shows nature of concentration, which are plotted rate against concentration. Some graphs are plotted concentration against time. So if you look here, there are 4 graphs totally, and each graphs explains for a particular order. So plot of rate versus concentration. We will see the what is the relationship between rate and concentration. So for zero order, it is a parallel to the concentration axis. That means whether you increase or decrease the concentration, there is no any kind of effect on the rate of reaction. That means rate of reaction is independent on concentration for zero order reaction. For first order reaction, as you increase the concentration, rate of reaction increases, and you will see the nature of a graph. It is a straight line passing through the origin. Again for second order, small change is there. Rate of reaction is plotted against square of concentration because it is a second order reaction. Again the nature is a straight line. For third order, nature of the line is straight, no doubt, but small change is cube of the concentration because it is the third order reaction. So rate of reaction is directly proportional to concentration of 3 molecules. So that is nothing but third order. So this is the nature of plots of rate versus concentration. We will see the next slide. So in this case now, the plots of integrated rate equations, we have plotted concentration against time, and on y-axis the factor is continuously changing, you may say, from starting to end. If you look the first graph, that is for zero order, it is concentration against time. As you increase the time, concentration of reactant decreases, and nature of the graph is a no doubt straight line, but it is in the decreasing manner, because of which we will get the negative slope. Second graph for first order reaction, it is log of concentration of A, or simply log A. So that is plotted against time. As time increases, log A value decreases. Again we will get the negative slope because order is in the decrement. Now the for second order, it is log of concentration, but it is in reciprocal form. So it is 1 by A on y-axis and it is plotted against time t. So nature is no doubt decreasing, but there is an intercept on y-axis. You may see the distance from origin up to the point which cuts to the y-axis. That distance is nothing but intercept, which we have revised after some before some time. For third order, it is 1 by A square, that is the square of concentration, and it is plotted against time t. Nature for second and third order is remaining same, that is in increasing order, but both the graphs carries the intercept. Remember this point. In the next slide we will see the next nature, that is plot of half-life periods versus initial concentration, that is 1 by a or 1 by a square for second order. For zero order, initial concentration is on x-axis, on y-axis there is a half-life period. For all the orders, half-life period is on y-axis and it is plotted against concentration. For zero order it is a straight line, that means as you increase the initial concentration, half-life period also increases. Now for first order reaction, as you increase or decrease the initial concentration, there is no any kind of effect on the half-life period. That means half-life period of the reaction is independent on the initial concentration of reactant. So this is the statement for first order reaction. There is no any kind of effect for half-life. For second order reaction, the nature is same as like a zero order reaction, but the reciprocal of concentration, initial concentration is taken on x-axis, that is 1 by a. So half-life period on y-axis, it increases with initial concentration decreases. That means 1 by a factor increases, T half increases. That means we can say that initial concentration decreases, then half-life period increases. So that is for second order. For third order, again the nature is a straight line passing through the origin, but it is again reciprocal factor, that is 1 by a square, that is the fractional one. So if you increase the half-life period, no doubt 1 by a square increases, that means initial concentration decreases. So these are the nature of the graph. Some important point can be used for memorizing. If the reaction completion is given in percentage, that time initial concentration must be taken as 100. And if the reaction completion is given in a fractions, that time the initial concentration should be always considered as a unity or 1. We will see the next slide. For a reaction of general type, Na gives product. So for zero order reaction, we can write K is equal to X by Nt. This is the general equation for half-life period equation. T half is equal to A upon 2 into N into K, where N is the order, T is the time, X is the concentration, K is the rate constant, and T half is the half-life period. For first order, for second order, and for third order, you can see the equations. We can use these equations to solve the numericals. We can use this formula for calculating half-life period. It may be order of reaction, it may be initial concentration, it may be rate constant by using these formulas. So these formulas are most important for the calculation or to solve any kind of numerical regarding chemical kinetics. We will see the next slide. Now the graphical methods. You will see here, for first order reaction, plot of log of a minus x against time t is always a straight line. For second order reaction, plot of 1 upon a minus x versus time is a straight line. For third order reaction, plot of 1 by a minus x square is a straight line. So for any order, that is nth order, we can write a general equation, a graph of 1 upon a minus x raised to n minus 1 versus time must be straight line. You can remember this statement only. So you can calculate for any order of reaction. When question will be how the nature of the graph, or if anyone asks a straight line graph obtained, then what will be the quantities on x or y axis. So you can memorize in this way by 1 upon 1 a minus x raised to n minus 1 versus time. So in this way, now in the next slide, graphical determination of order of reaction. You can memorize order of reaction for first order, for zero order, for second order, or for third order. What will be the equation, what will be the nature of straight line, or which axis should belongs to which quantity. You can memorize in this way. What will be the slope and intercept on y-axis. So there are mentioned factors. If you see for zero order, it is x is equal to k0 into t. So that is the equation. For x-axis, you considered uh, time, and for y-axis there should be a concentration x. So slope will be k0 and its intercept will be 0. That means it line goes through the origin, passing through the origin, that is the straight line. In this way you can explain for first order, second order, and for any order, that is the nth order. The last equation, a minus x raised to 1 minus n is equal to n minus 1 k2 into t plus a raised to 1 minus n. That is the equation for nth order. And then you can see the x-axis as well as y-axis, and you can see the intercept also. So these are the memorizing facts or tricks which we can use for solving the numericals. So you may study from this lecture also. This all the no, it is present in your notes also. So you study one by one point and use these notes for the calculation of your numericals which are present in assignment or in quiz. And if you have any query, you may communicate. So thank you so much.